Okay, so the goal of this video is to teach you how to represent different situations using math. We can use equations, tables, and graphs. And now that we have worked with them, manipulated them, we know how to work with equations. And we've built tables, we've even looked at tables to find the rate of change in things. We've also looked at graphs. So now we're going to look at them as one cohesive group to help us solve situations. All right, so Jim saves $144 before being allowed to buy a puppy. After bringing the puppy home, he had to withdraw money to buy food and toys. How much money is in the account when he brought home the dog? How much money is withdrawn each week? And does the table represent a linear relationship between the number of weeks and the amount of money left? So right away, when he brings the dog home, he has $144 in the bank. He withdraws, let's see here, what's the change in each one of these? So what's going on between these two numbers? He takes out $12 every single week. So he is withdrawing $12, okay? Does the table represent a linear relationship? If we look at this, are each one of these decreasing by 12? The answer is yes, and each one of these is increasing by 1. So it is linear. Yes, it is linear. So they want us to write an equation to represent this relationship. Okay, so if we know the rate of change is a negative 12, then y equals negative 12 weeks. So every week he's spending $12. Like for example, 1 week, $12. 2 weeks, $24, but it's a withdrawal, so it's negative. Okay, and he started with that 144, which is our zero term. So that's why we use that one. So what does the number in the variable represent? Okay, so if we look at this, this represents our slope or a withdrawal of $12. The 144 would be our y-intercept, which represents the money, $144 he started with. Okay, if we look at this, x would be our weeks, and the y would be the amount of money, we're going to have to put it down here, at the end of each week. This is one of those videos where it's helpful to print out my notes, because then you can just fill it in as I go, or as we go together. All right, so let's look at Sally. She bought a new puppy. How much money was in her account when she brought the dog home? Now, Sally has a graph instead of a table. So if we look here, she had $100 when she first brought the dog home. If we look as the weeks increase, how much money is she taking out? She's taking out $10, because look, week 1, if we look here, it's $10. Week 2, $10. 3, 4, 5, 6, all of them, $10. Is this linear? Yes, because it forms a straight line. So it does, between the number of weeks and the amount of money left, it is decreasing. So let's write the equation. We know it's going through at 100, so we know that we are adding 100. Okay, and it's a decrease of $10 per week. So a negative 10 over 1 was our slope. So our y-intercept represents, again, the amount of money at the end of each week that negative 10 represents the slope, or just like in this problem, it represents a withdrawal of $10 every week. Which is a negative 10. our slope, or excuse me, our x here represents the number of weeks. Notice we can just write amount of money and weeks if you wanted to. So you could just put amount of money, and that's a big in parentheses. And then our $100 is what she started with. Okay. Let's look at a couple more situations. Jeremy has decided to learn to rock climb over the summer. He can pay a daily rate of $10 plus an equipment rental fee of $8. Write an equation to model the situation. So he pays a daily rate of $10. So $10 per day, and he's got to pay that equipment fee. So if he doesn't rock climb any days, all right, that's independent, right? He's not going to pay anything but $8 for the equipment fee. The dependent is the total cost. So the number of days is our IV, and our DV is the total cost. If he goes 1 day, he's going to pay 1 times 10, which is 10, plus 8, which is 18. 2 days, he's going to pay 2 times 10, which is 20, plus 8, which is 28. And you're going to see a pattern in the table. So it's kind of nice because then you don't have to fill it in as crazy. Is this linear? The answer is yes. Is it proportional? The answer is no, because of that $8. But it is linear because it's increasing at the same rate every day. All right, so if we created a graph out of this, we would see that every day, so our IV needs to go at the bottom. So these are the number of days would go at the bottom, and our total cost would be our Y. So let's do that right now. So cost, and these are days, and we need a title. Our title would be rock climbing. Oh, I forgot my L. Okay, so if we graphed this, we need to graph our table. So starting at 0 would be 8 and going so on and so forth. So we should make maybe our table increase by 5. So 5, 10, 15, okay, 20, 25, 30, 35, 40, 45, 50. So we said at 0 months it's 8, or number of months. Oops, I'm on the wrong one. Just kidding. Rock climbing cost. If we do this one, the number of days was 1, and it cost us, oh shoot, I put that on the wrong thing then. I've lost my scale when I moved back. 20, 30, 40, 50. I'll erase that when we get to that next question. Okay, so here's 8 at no days. At 1 day would be 18. 3 days would be 28. Oh, 2 days would be 28. 3 days would be 38, and so on and so forth. So at 4 days of rock climbing, he would pay $48. If the total cost was $138, how many days did Jeremy climb? We can plug in that 138 into the equation. Y equals our 10x plus 8, and we can solve. By taking 8 away on both sides, I know that he spent not on the equipment fee, but on just the days $130, which means if I divide that by 10, he would have gone 13 days. Okay, that's actually our do now, and I don't know why it's right there. So we're going to skip over it. All right, try this one for me. Write an equation to model the situation, define your variables, fill in the table, is it linear, and then we'll go from there, okay? All right, so I'm gonna go through it, so make sure that you paused the video. All right, there's a shipping and handling charge, and for a set of 4 wheels costs $24. Okay, so if we were looking at this, our independent variable is the number of sets of wheels. The dependent variable is the total cost. So if I buy no sets of wheels, if I just basically call them up and say, I don't want any wheels, just ship me a box, I pay $14. As silly as that may be, I could have called them up and asked them to do that. It would be uneducated of me to do so, though. So if I wanted to buy one, I could know that the difference is going to be $24 per set of wheels. And I'm going to add $14 for shipping to that. So if I buy one, I'm paying $24, but I also have to pay the shipping. So really I'm paying $38. If I buy two, I'm paying $48 for the wheels plus the $14 for shipping. And I'm going to pay a total of, let's see, that's 58, so that's 62. And if I buy three, I'm going to pay, let's see, four more here would be 52, then 20, so 72. So if I add the 14, that's 86. Okay, so how much if he bought 4 sets? Okay, so if he buys 4, we could plug it in. Y equals 24 times 4 plus 14. 24 times 4 gives me 96 plus 14 for the shipping would be $110. All right, so what if the total cost of an order was $182? We can plug that in for Y and solve for the number of wheels, X. So if I take away the shipping cost, which is $14, I am left with 182 minus 14, which is 168, equaling 24x. If I divide by 24, I know that the number of wheels is going to be, or groups, excuse me, the number of sets is going to be 7. Okay, so 7 sets. All right, and that's all I've got for you today. See you next time.